Good morning, everyone. Dr. Vaughn. I'm going to make a video right here at the start of the week. We're in section 7.4. We're working with vectors. And here is question number 1 from the homework. So these are kind of easy. We're doing addition of vectors, which is where you put each vector with the foot at the toe of the next. So A plus B plus C is going to be commutative. It's associative. So the parentheses don't really matter. We could add B and C together and then add A, or we can just do A and then B and then C. So we're going to put A, and then B is going to go next to it, up over like this way, and then C is going to go off of the end of B up over this way, and then we connect the toe of the original vector A up to the tip of that last vector in the chain, which is C. So we're going to just look at these pictures that they give us and select the right one. So this looks like they've turned A around, so they have minus A and B and then C. So here's B plus C, and they've added that to, well, A is coming up over this way, but the vector would go from here. They have everything backwards, so this would start at the base of A and go up to the tip of A. So this one's backwards. All right, here we have A seems to be going in the somewhat right direction, but B and C have been turned around. They're going the opposite way, so they've negated B and C before they added them together. Here we have A has been turned around, B and C have both been turned around, and then everything's been turned around. Hopefully this is the right one. Here's A, yeah, here's B, here's C, here's B plus C. So we go from A, and then we do B plus C. So this is the resulting vector A plus B plus C. So that's the correct choice, sketch C. All right, let's skip up. Let's try maybe number 5. Okay, use the parallelogram rule to find the magnitude of the resultant of the two forces shown in the figure. So the sum of the two forces is the sum of the vectors, and we're going to take this vector and add it to that one over here. So there's the 7 pounds of force going this way, and then we'll find the length of the resulting vector. So once we find the sum of those two vectors, the length of that sum is what we're looking for. We're going to use this rule that we can make this parallelogram. So when you complete this parallelogram over there, and then you look at this angle, which is the supplement of the one that they give you. So that's 120 degrees over here because they have to add up to 180. So when I take the this angle over here, cosine 120, I can use the law of cosines with this side and this side for this triangle that's formed along the diagonal of this parallelogram. So the law of cosine says the length of the hypotenuse is this diagonal of the parallelogram, which gives us the length of the force. The length of the diagonal of the parallelogram is going to be equal to the square of that is a squared plus b squared minus 2 times ab cosine of 120. So we'll see if we can't do this together. We're going to take 7 squared plus 15 squared, 7 squared, 49, plus 15 squared, and that's 274. And I'm going to subtract 2 times 7 times 15, so that's 30 times 7 is 210, minus 210 times the cosine of 120 degrees. And the cosine of 120 degrees is negative 1/2. So when I subtract this 210 times negative 1/2, I'm actually adding 210 times positive 1/2, which is adding 105. So I take 274 plus 105, and you get 379. Now, that's the square of the length of the diagonal. So now I need to take the square root to find the length of the diagonal. And the square root of 379 is 19.468. And they want to round to the nearest tenth, so we'll round that to 19.5 pounds. Let's see how I did. All right, good job. We'll try one more. We got a couple minutes, so we'll jump up and look at question 10. This looks like it's pretty much going to be the same. The only, let's see, the sum of these two vectors is going to be kind of coming up over this way. So, you know, you move this 26 pounds over here, you do the resulting vector over here, and that seems like it's going to be pretty much the same question. We'll work through the details of it. Why not? It's really fun. All right, so we're going to have the length of the diagonal squared, x, if you will, squared. What we're looking for is going to be 25 squared plus 26 squared minus 2 times 25 times 26 times the cosine of the supplemental angle, because we want to get the angle that's between the two vectors once I've transported it, and then so that I can get the diagonal. All right, so 180 minus 117 is going to be 63 degrees. All right, so we're going to take, with the calculator, 25 squared plus 26 squared. So that's 1,301 minus 2 times 25, which is 50, times 26 times the cosine of 63 degrees. And that turns out to be 590.187. And so I'll take 1301 minus 590.187, and I'll get 710.81, trying to keep as many significant digits as possible. And now I'll take the square root of that previous answer, and I'll get 26.66. So rounded to the nearest tenth, that should be 26.7. Keep our fingers crossed. And there we go. All right, well, I hope this has given you a good start on your homework for this week. I try to keep these videos fairly brief, but I'll see if I can't push one out for section 7.5 shortly. Have a great week, and as always, let me know if there's anything I can do to help you along the way. Have a great day.